There we go. Okay, 130, 23, right? Okay, our objective is going to be graphing linear equations, and we'll call them functions as well, or linear functions. Okay. Graphing linear equations, or we'll call them linear functions. Okay, and we'll talk more and more about what a function is as we progress. Now, the word linear, when we see the word linear, we're always going to think a straight line, okay? The word linear, always think straight line, okay? In our warm-up, we graphed an equation that was in slope-intercept form. This one here is in what we call slope-intercept form. Okay, and we'll talk more about that tomorrow. But you know, it's slope-intercept form because we have a slope 2/3, and we have an intercept of -5. So to graph this, we'll just go to -5 on the y-axis, right? On the y, go down 1, 2, 3, 4, 5. It's my y-intercept. And that'll apply my slope, right? Up 2/3. It's a rise or run of up 2/3, so it's just up 2/3. I like to do lots of points because, you know, lines are forever long. So when I say lines are forever long, let's connect the dots and put arrows on it. So when I connect my line, I put arrows on it because we know the graph goes forever in both directions. Now B is the same type of line, which just has some invisible numbers. So let me rewrite it, okay? So I'm going to rewrite B as y equals a 1/1x plus 0. Sometimes having the invisible numbers is helpful. And then we have our y-intercept and we have our slope. So then I'm going to start at 0. I'll go up 1/1, up 1/1, up 1/1, and of course, you know, nice long line, put the arrows. Okay. And I'll wait for you because I want to make an observation. So the original question says y equals x. Everybody listening? So think about this. This point here is 1/1. This point here is 2/2. This point here is 3/3. -1, -1, -2, -2. Isn't the y value always equal to the x value? And that's why it runs along this line. Okay. C. Now C has, in a sense, a 0x. We don't have to write it, but you could say plus a 0x. But we know that's got to be horizontal, right? So I'm just going to go down to -3, and I'm going to draw a horizontal line. One of the things I like to do as a teacher is get you know why. Why does it work? Well, if I look at every point, every one of these points always has a y value of -3. Has a y value of -3. Y value of -3. So y is always equal to -3, and that's why it's the horizontal line right there. Slope is 0. Okay, now to do D, what I should do is first get it in slope-intercept form. So I'd like to get it into slope-intercept form. And to do that, we're going to solve for y, right? We're going to solve for y. And I don't know if it's been a while since you've done math, you may have forgotten how to do this, but I'll do it with you. So we need to get y by itself. So I'm going to go ahead and subtract 3x from both sides. Minus 3x, minus 3x. I'll have a 4y equals, well, you can't really add those. That's an x variable, and that's a 12, which is a whole number. So it really is just negative 3x plus 12. Okay? And then I'm going to divide by 4 everything, and I'll have an answer of y equals negative 3/4 x plus 3. Now I can graph it. Now it's in slope-intercept form, and graphing it would be pretty easy. I'll start at positive 3 as my y-intercept. And then on my slope, I'll go down 3 over 4. 1, 2, 3, 1, 2, 3, 4. And I can do it again. Kind of goes off my paper, but there's my line. Sometimes when it's in standard form, there's an easier way to graph it. I'll show you. So sometimes we call it cover-up method. Am I going too fast? Okay. So you cover up the x, what's y going to equal? Just solve y. Cover up the x, what's y equal? Boom. So you cover up the y, what's x equal? Boom. 2 points across. And that's what? It's by graphing by intercepts. That's just another way to do it. Okay, now, next one. Is the point 2, negative 0.5, a solution to this? Well, there's two ways. We can try and figure out 2, 0.5 does not look like it does. I would say probably no, because it's right about here. Probably no. Or we could test the point. Because sometimes you can't tell, but I'm pretty sure right about here it's not. But if we test the point, that's an x value, that's an y value. I will rewrite as 3, and I'll put 2 in for my x value, plus 4, and I'll put 0.5 in for my y value. And if it equals 12, then yeah, it lies along the line. If it doesn't, then it does not. Then it's not on the line at all. So I just plug my 2, my x value in for x, my 0.5, my y value in for y, and I'll solve it. 6 plus 2 equals 12. Well, that's not going to work, is it? You're going to get 8 equals 12. That's not true. Not true. So you know that it does not. It does not lie on the line. Okay? And I can see it, but sometimes you can't see it. Sometimes you have to test it, and that's where you test, okay? Okay, let's turn the page. I'm not going too fast. I'm doing okay? Okay, good. All right. Example 2. Given A and B, find their, that should say midpoint, not mind point, and the length of AB. So real quick, I'm just going to do a real quick sketch. Real quick sketch. Then I'm going to give you some formulas, okay? Real quick sketch. So point A is, it should be midpoint, not mind point. Yeah. Oh, I did. Mid. Thanks. Thanks. A might be up here at -1, 9. And B might be about here at 4, -3. Okay? And so if we're to connect dots, I've got a line segment. It's not a line, it's a line segment. Okay? That is a line segment. It's just a piece of a line. So it should have a middle or a midpoint, and it should have a length. We should be able to find out without measuring. So first of all, here is the equation for a midpoint. So midpoint, it's an average. So the midpoint is x1 plus x2 over 2 comma y1 plus y2 over 2, okay? That's how you find a midpoint. It's just the average. midpoint formula. I'm going to highlight it because that's one of the important formulas I'm going to need. Right, there you go. Got it highlighted. Every point has an x and a y value, right? The formula has x1, x2, so first point, second point. The formula has x or y1, y2, so first point, second point. So I like to call this x1, y1, x2, y2, okay? And I'm just going to put the numbers into the midpoint formula, okay? So then I'm going to have an answer of, let's see, I will have a -1 plus 4 over 2 comma, a 9 plus a -3 over 2. All right. All I did is I'm just adding the x's, dividing by 2. That's all. Add the x values, divide by 2. Add the y values, divide by 2. That's all I'm doing. So then I'm going to get a 3 over 2, and I'm going to get a 6 over 2, which becomes a 1.5 comma 3, okay? Which is probably right about here somewhere, okay? There's my midpoint. And now I know it's at the point 1.5, 3. Okay, I'll slow down. Okay, that's my midpoint. Sure looks right, doesn't it? Because it is. That's why it looks right. It is right. And then to do the length. So the length or distance depends on whatever book. It's the same thing. Sometimes you'll see find the length. Sometimes you'll see it'll say distance. Okay, they're asking for the same thing. What's the length of the segment, or what's the distance between A and B? So the distance formula is big square root of x2 subtract x1 squared plus y2 minus y1 quantity squared. Okay, that is the distance formula. I'm going to highlight that too because it's important. Okay, so I'm going to do the distance. And big square root of, let's see, x2 is 4, subtract x1, which is minus a minus 1, double negative, right? Because I'm going to go 4, subtract a -1, so I get a double negative there, plus my y2, which is -3, subtract y1, which is 9 quantity squared. Okay, so I just put my values into the formula. And I know that 4 subtract a -1 is like a double negative, so it's like plus, right? So to simplify this, I'd have a 5 squared plus a -12 squared. You okay with me? Please stop me if you get confused. My job is to help you. Okay, then that is 25 plus 144, right? Which is the square root of 169. I think that's actually a perfect square root. If not, we'd just go with the decimal, but I'm pretty sure that's 13, but square root of 169, I'm pretty sure it's 13. And yeah, it's 13. So the length is going to be 13. Okay. Okay. Last example, example 3. I've got two lines. I got a 2x plus a 5y equals 10, and I have a 3x plus a 4y equals 12. Okay, I'm just going to write them down so I can work with them. Okay. Probably the easiest way to graph these is with that cover-up method, right? Let's just do the cover. So let's do. I'm going to do the first one. I'll do in blue, and let's see. I'll do the second line in purple. I like colors. So I like the cover-up method. It's the easiest way if they're in sentence form to graph. So I'll do the blue one first, and I'll wait for you girls. You're getting out your colors, aren't you? I like colors. Colors are the best. I'm a big believer in colors. So let's do this together. Everybody watching? If I cover up this 2x, what would y equal? 2. So I'd have a y-intercept of 2. You with me there? If I cover up the y, what's the value of x? So I have an x-intercept of 5, and there's my first line. Okay. We'll do the same thing with the other line. So, if I cover up the x, what's the y value? Everybody agree? 3, y equals 3. And if I cover up the y, what's the x value?
4.
And if I connect the intercepts, so the point of intersection, what we're looking for, is kind of hard to see. I could guess. And it looks like it might be about 2.5, maybe 1.5, maybe. It's not a bad guess. It's probably pretty close. But what if I need the exact answer? So if you need the exact answer, we're going to go back to Algebra 1, where we did the elimination method, okay? And if you don't remember it, I'll go slowly. So to do the elimination method, I'm going to rewrite these two equations together. So let's use the elimination method. So let me rewrite my 2x plus 5y equals 10. And right underneath it, I'll put the 3x plus my 4y equals 12, okay? So elimination means to eliminate, to get rid of. So we're either going to get rid of the x's and find y, or we get rid of the y's and find x's. It doesn't matter. We're going to eliminate the x's to get y's, or eliminate the y's to get x's. Now, I need to make them opposite. So I'm going to do this. I will multiply equation 1 by a 3 and equation 2 by a -2. Why would I do that? What's the point in doing that? What is the point? Why would I do that? Anybody see why I would do that? Why would I multiply this one by 3 and this one by -2?
Get rid of x.
I'd get rid of x. I would have a 6x, right, and a -6x, and they would eliminate when I add them. Does that make sense? So I made them opposites. Positive 6x, -6x, just by multiplying them. Okay, so now let me rewrite equation 1. So equation 1 now is a 6x plus a 15y equals a 30. And equation 2 is a -6x minus an 8y equals a -24, okay? If I add these two equations, we'll eliminate our x's. Am I going too fast? Slow down for a second.
Yes, please.
Lexi, give me thumbs up when you're ready. Okay? So, let's add. So the x's cancel. I'll have a 7y equals 6, right? Divide by 7, and I get y equals 6/7. Boy, I wasn't even close. Look at my answer. 6/7, 1.5. I wasn't even close, right? So the graph is nice because it looks nice, but that's not even close to the answer. This 6/7 is the answer. So now I also want to find x. Let's find x. And so I will substitute. I'm going to substitute. So I'm going to take my 6/7 and maybe I'll plug it into right there. You can plug it into either equation. I just picked that one because it looked easier, okay? So I'm going to take equation 1 again. And I go 2x plus 5. And instead of writing my y, I'll write 6/7. I'll substitute 6/7. Okay? And now, yeah, I'm gonna have to do fractions, but I can handle that. I can live with fractions, okay? So I'm gonna simplify this. This is gonna be a 37th, okay? I'll subtract 37ths. Now, what is 10 minus 37ths? Well, I'm gonna have to do a little bit of math. I gotta go back to middle school math, don't I? Okay. 7 goes into 30 how many times?
47.
Okay, so 7 goes into 30, like 4 with 2 left over, right? So really, you've got, in a sense, you've got 10 minus 4 and 2/7, right? So what is 10 minus 4 and 2/7?
5 and 5/7.
Is it 4 and 5/7? No, it is 5 and 4/7. It is going to be 5. Thank you, Lexi, and 5/7. Okay, which is the same thing. Now divide by 2, right? So then, how do we divide 5 and 5/7 by 2? Well, I'm going to take it back and rewrite it as 47 divided by 2, right?
It's 37.
It is 35 47.
It's supposed to be a 4. What?
Oh yeah. No, that's
The big number.
where am I making a mistake already? Day 1, where am I making?
The 5.
That 5 right there.
5. 5 is 5 is 4. Yeah, because no,
Here comes the calculator.
5 is 35 over 7. And
Yeah.
then plus 5 is 40 over 7.
Right,
Divided by 6.
right. It is 20 over 7. Yes. It is 20 over 7 because 47ths invert and multiply, right, makes 27. Okay, now what do we get? Our answer. Whew, fractions, huh? Our answers are 6/7 and 27, which is 2 and 6/7. Wow. Aside from the fractions, that wasn't too bad, but the fractions really made it hard, didn't it? Now, okay, as I stop this recording, I'm going to make a suggestion, okay? Let me stop the recording, okay? Stop, okay?